Today we're going to look at section 1.4. I think it's our second to last section in chapter 1. Absolute value. Does anybody remember what the symbol is for absolute value? What it looks like?
It's not like a figure eight.
That's infinity. You're thinking of the figure 8, that's an infinity symbol.
Oh, yeah.
Does anyone remember what absolute value looks like? Okay, so absolute value symbol looks like this. Was that, you remember that? The 2 bars?
No.
Some people? No?
Do we have to do
All right, well, that's what the absolute value looks like. Question?
Do we have to?
Do we have to? Yes, you do. All right, so reminder, absolute value is written just like that. The way you pronounce that is the absolute value, and then just say what's inside. What's inside the bars?
1x.
Yeah, the absolute value of x. Now, what absolute value
You guys, you
is,
don't have to write any of this right now.
as long as you know it, you should know it. What absolute value measures is the distance from 0.
So on the top of your notes, you have what it says absolute value measures. You're gonna write you can write distance from 0, or you can write the distance the number is from 0. It's gonna help you to remember. So on that first line of your notes, you're gonna write distance from 0.
So what does that mean about absolute value? If it measures a distance, what kind of numbers do you get when you measure a distance?
Positive or negative?
What did you say, Joe?
Positive numbers? I don't know.
Positive?
Or negative numbers?
Negative. Does anyone think you can get negative numbers when you measure distance? Gemini?
Probably not.
No. So when you measure distance, you could either get 0, like if you were saying what's the distance between 2 points that are at the same spot, it's 0. Otherwise, it's always positive. Okay, we're going to keep that idea in mind when we solve some equations. Okay, because not every absolute value equation has an answer.
And guys, inside those absolute value brackets, it's okay to have a negative number. It just can't. Absolute value can't equal a negative number.
So what do you think we call an equation that has that symbol in it? What kind of equation do you think we call it?
What's it called again?
An equation with absolute value.
Yeah, it's called an absolute value equation. So that's what we're going to be solving today. We're going to solve equations just like you guys did before, but the key difference is going to be how many answers you get. How many answers did we usually get if it wasn't infinity and it wasn't no solution? We usually got 1 answer, right? Well, today we're usually going to get 2. Usually. So usually we're going to get 2. It is possible you could get 1. And it also is possible you could get none, but most of them are going to be kind of the standard case where you always get 2.
I think you asked me the answer.
Well, I can just make up something, okay. So that means you have to take the absolute value, right? What kind of number is absolute value? Mr. Roy just said it. It always comes out to a...
Positive.
Always comes out what?
To a positive.
Always comes out positive. No matter what you fill in for x, positive, or it could come out to 0. But does it ever come out negative?
Nope.
So how could that ever equal -4? Could it?
No.
No. That's a problem that would have no solution.
So remember, we're doing this. We're measuring something. All right. Even if we had, like, if we drew. If I looked at -3 and 3, that's why absolute value is always positive. If I looked at negative 3 on the number line, right? How many spots away from 0 am I?
2.
1, 2, 3. It's negative, but it's still 3 spaces away from 0. Same thing here. From positive 3 to 0, 1, 2, 3. That's why absolute values, we can never measure distance as negative. Even if I drove somewhere in my car backwards, the speedometer is still going to go up. It's not going to go in reverse. Right? It never happens that way. Right? Unless some of you guys have the ability, you guys are all car people, you'll be able to set it up and make it go backwards. I don't know. But it doesn't work that way.
We can go stroke engineer that thing. Let it work.
All right, so guys, on your notes, right, you have, we're going to write some steps to solve absolute value equations. This is just the process of getting it, because again, it's almost like we want to treat the stuff inside the absolute value as one big variable, as like one big letter that we want to get by itself. All right, so first step, we want to make sure, all right, that we want to make sure the absolute value expression is by itself on one side of the equal sign. It can only be absolute value. There can't be anything, any number to the left of it. There can't be like after the absolute value, like plus or minus a number. It can only be the absolute value.
Just to show you guys an example, that's an example where the absolute value is by itself. Okay, nothing else on the outside of it. That's an example where it's not by
It's
itself.
not by itself.
Okay, so we'll talk about
And
how to solve it.
guys, we're probably, as far as when the absolute value is not by itself, we're probably going to have two different types of examples. Two different types of problems we'll look at where the absolute value is not by itself. But if the absolute value is by itself, and this has the absolute value, and it equals something, perfect, we're all set to go. Now, what if that absolute value you had equaled a negative number? Would you have to do any work?
He means like that.
Would you have to like solve anything?
No.
If I had something like that, how come?
Because it can't be.
There's no solution, right? Absolute value cannot be negative because we're measuring distance. So it can never be negative. All right? So you want to make sure the absolute value is by itself on one side. Guys, if you don't want to write all this, you're going to say ensure or make sure the absolute value is by itself on one side of the equal sign. Right? So you want it to be absolute value. Like the example Mr. Hager showed you, the bars equal 0. Say 2. I don't care what's inside the absolute value, but if it's by itself, then it's fine. If the absolute value is by itself, doesn't matter what's inside here. There could be a whole bunch of terms inside the brackets. As long as whatever's inside the brackets is by itself, you're good. All right. Now, a couple different situations. And I'll leave this up here, guys. You're not finished copying it down. I'll leave it up there. All right. Now, a couple different scenarios that we could have. If there's a number attached to the absolute value, and I want to show the I think you have an example on your notes. Am I correct saying that? Yeah, you do. All right.
Like this one.
And they have them written on their notes too, mistake right below it. So if there's a number attached to the absolute value bars, divide both sides by whatever's attached. Just like when we had if we had 3x equals 6. All right, we would divide by 3, and that would get x by itself. We'd be able to solve. Same thing here. We can think of the absolute value as like one big, all the stuff inside is like one big variable. And to be able to solve absolute value, that the bars have to be by themselves. Just like when we solve for an equation, right? The variable has to be by itself. When we're doing these, the absolute value has to be by itself before I can solve. Right? They can be bars, equal sign, number. That's how it's going to be set up every time. Now we might have to do a little work sometimes to get it to look like that. But again, we're going to show you the two different scenarios that you'll see. If it's like this, I'm good to go. All right? But sometimes it's not always going to be like that. All right? So if there's a number outside, we're going to divide both sides, all right, of the equal sign by that number. So let's look at this example. We're not going to solve the whole thing. All we're going to do is just write down how we get the absolute value by itself to be able to solve it. So someone tell me, what am I going to do here? Based on the notes that we just wrote, if there's a number attached to the absolute value bars, divide both sides of the equal sign by that number. Mackenzie, what's the number attached to the absolute value? So here's the absolute value right here. This is the bar, all right? What's attached to it?
5.
What's to the left of it? Not what's inside of it, what's outside of it. 3, right? So what am I going to divide by? 3, right? That's the number attached to the absolute value. Like I said, if you want, think of the absolute value as one big variable that we want to get by itself. So we divide by 3. Divide by 3, divide by 3. On this side, is this going to cancel out? The absolute value bars don't disappear. We're not at that point yet. All we're doing is getting it set up so we can solve it. Absolute value bars stay. And there you go. Again, we're not ready to solve yet. We're just getting it set up so we can solve. So like I said, think of it as one big variable. Get it by itself, then you can solve. All right? So that's one situation we might have where we might have to do a little bit of work before we can solve, before we get our 2 answers. Here's another one. I'll leave that up there so people can see. Another one. Now, this is kind of a... Stop there. So, if there's a number attached to the absolute value, just like this, right, there's a number attached, but also another number on that side of the absolute value. Right, it might be +2, -5. There's something else. There might be something else right here, like outside of it to the right of it. So you got the number attached, but also another number on that side of the equal sign with the absolute value. All right? So there's a number attached, but also another number on the outside of the absolute value. All right? So think of it if I had something like this. I had something like that, right? Again, as an equation, right? What would be the first thing I do to solve that? Sophia? -2. -2. 3x equals 6. What would be the last thing I do, Madison?
You would divide by 3.
Divide by 3. So like I said, think of the absolute value. You don't have to write that down. I'm just showing you an example. Think of the absolute value as one big variable. All right? We're going to do it. When we do it, we're going to do it the exact same way. So just like we kind of did here, we'll do the opposite operation on both sides. So whatever's outside the absolute value bar, we'll plus or minus that first, depending on what the sign is. Then we'll divide by the number attached, like we did in the first example. So now we move that number, right? Now we have the number outside and the number attached to the absolute value bars equals something. Then we divide just like we would in, just like we did in the first example, the first situation. So again, these are situations where we can't just go ahead and solve. We got to do a little bit of work before we can follow the process to be able to solve it. So these are ones that like aren't set up for you. You've got to do a little work to get them set up in the right format to be able to solve that. And these are the two ways. These are the two ways it will happen. One way will be there's a number attached, divide. The other way it could be you might do a little bit more than that. You might have to add or subtract on both sides and then divide. So you can get either or. You might get either or situation. All right. So I might make a little more sense, guys, when we show you an actual example. All right. So just like we did up here, right? Again, think of this right now. I don't have time to think that way, but think of this as one big variable. Right? We want to get that variable by itself. So based on the steps that we wrote, what would be the first thing we would do? Maybe they know based on the notes we just wrote, or the step we just wrote. Do the opposite operation on both sides, then divide by the number attached. So let's clarify this right off the bat. All right? X. What's the number attached to the absolute value? 6. We're not going to touch that, so we're going to divide by that at the end. What's my only other option outside of the absolute value? Mallory?
Negative 14.
The negative 14, right? So what am I going to do? So Mr. Hager's doing that. He's just blocking it out. If we thought that as this one big x, right, one big variable, all right, you can do it. So like Mallory said, she said negative 14. So what do I do, Mallory?
You do plus 14.
I'm going to add 14. Just as if it was like 6x. 6x minus 14 equals 10. I'll plus 14. All right? This cancels out. Here's my equal sign. When I do 10 plus 14, guys, what do I get? 24. Perfect. Good. Now I'm just going to bring everything down. 6a minus z equals 24. Now, last step. Again, if this was 6x equals 24, what would you do? If it was 6x equals 24, if you're going to solve it, what would be the last step you'd do?
Divide.
Divide by what number, Sophia?
6.
6. I'm going to divide by 6 on both sides. On this side, even though I can't see it, all that's going to be left is the absolute value. What's 24 divided by 6?
4.
No? 4. Good. Perfect. And all I'm going to do now is, this cancels out. It leaves me with my absolute value. A minus 7 equals 4. I'm done. Now I'm ready to solve.
So you don't even need to look inside that absolute value
No.
until now.
Until now. Right, the absolute value is like, if you get an example, if you get a problem that's like this, right, absolute value equals something, you're good to go. You can go right to the steps we want to talk about next. If there's stuff outside, like we just showed you, again, if there's a number attached, nothing else, just divide on both sides. If there's a number attached, and also plus or minus another number, opposite operation on both sides, then divide. So those are the two situations you might have to do a little bit of work before you can actually solve. Right? Now we're at this point. Now we're at the actual point where we can solve. It's set up the correct way. All right? Now you're ready to solve. That's why I say here, guys, I think of like the absolute value bars like jail. All right? You know, anybody ever see like Shawshank? Ever see the movie Shawshank Redemption? No, you guys are probably way too young for that. It was about this guy like he like breaks out of jail. Like he digs like super long tunnel. And he breaks out of jail.
Oh,
If you're breaking out of jail, do you want anybody?
Yeah, I've heard of that.
If you're breaking out of jail, do you want anybody around you?
Yes.
You want people to know about it?
No.
No, you're gonna get caught, right?
Yeah, Joe.
That's what's happening here. You're behind bars, right? You want to break out. So here's the other. This is the other side of jail over here. On this side, where the bars are, you want nobody else around, so you can break out. So at this point, when there's nothing else outside the absolute value bars, you can break out. If there's stuff around the absolute value bars, you can't break out. You got to get those people away from you, so then you can break out. Let's look at step 2. All right. Now we're at the actual spot where we can break out. So we're going to eliminate the absolute value bars by splitting the original equation into 2 equations. So we're going to split it. As soon as we split it, we're going to draw 2 arrows. When we split it, the absolute value bars then go away. Once we're by ourselves, nobody else is around, no one's looking, then we can break out of jail. But we got to make sure we're by ourselves first. If we're already by ourselves, if you got a problem where it's already by itself, it's easy. It's an easy breakout because no one's around. You don't have to hide. All right. But again, you can't break out till the absolute value bars are by themselves. Like we just showed you in the first 2 situations. If there's a number next to the absolute value bar, divide. If there's a number, absolute value bars plus or minus, do the opposite operation on both sides, then divide. The absolute value bars have to be by themselves. Absolute value bars, equal sign, number. If there's people around, you can't break out. You'll get caught. You got to make sure that no one else is around, then you can break out. All right? So now we're going to want to take those absolute value bars and we're going to split it. All right? Okay, well, hold on one second. And guys, on your notes, what I show you guys next is basically going to explain what's on your notes. I don't want to be mistaken. I didn't want you guys to have to write this whole big next step. But I think once I explain what's written here, it's pretty much, on your notes is like, it's basically this, but written in symbols. Right, so none of this stuff you have to write, I'm just gonna explain. All right? I'll leave it up here in case people didn't get all that. All right? So basically, I'm just gonna read this, guys. You do not have to write this down. The first equation when you break out, again, you're going one way, and you're breaking out of jail, you're kind of going one way as yourself, right? You're yourself, you're nobody else, right? The only difference will be is you're going to write it without the absolute value bars. It's the same exact equation, the only difference will be no absolute value bars. If it was a minus 7 with the absolute value bars, you're just going to write it a minus 7 equals whatever equals 2. No absolute value bars. So that's pretty easy. It's the same exact equation, no absolute value bars. You're going one way, right, as yourself. Now, again, if you're breaking out of jail, if you're going like somewhere far away, no one will recognize you, so you might be able to go as yourself. But if you're going to stay in the area where people know you, that's when we get into the second situation. All right? Again, kind of wordy. Don't worry about it. Let me explain. So the first one, the exact same equation, no absolute value bars. The second one that we write, again, this is kind of like the disguise. It's going to be the exact same equation. The only thing is no absolute value bars. When we write these, when we split them, we never write them with the absolute value bars. We split them, and this is going to kind of be like you're kind of putting a disguise on. It's going to equal a negative, whatever it equals, you're going to make it negative. So you can, or a positive, right? You're going to do the whatever is. If it's positive, make it negative. If it's negative, make it positive. You're always going to do the opposite. So one way will be the exact same equation, no absolute value bars. The other way is going to be no absolute value bars, but opposite sign. If it's positive, make it negative. If it's negative, make it positive. Right? So someone tell me, when I split now, I want to get rid of the absolute value. How's my first one going to be written? When I split, how's my first one going to be written? The first equation that I write. We just talked about it. How's my first equation going to be written? What's the one thing that's going to be different from the original? What won't it have that the original has?
Is it not going to have the bars?
No bars, right? So we're breaking out now, right? So the first one we write, exactly the same, but no bars. The second one we write is going to have two things different. What's one thing that's going to be different from the original? Both of these are going to have this. Both equations we write are going to have no what? We're breaking out, right? So we're not going to have any more. No more what? Bars are gone, right? You're breaking out of jail. The bars are gone. The bars are going to be gone in both equations that you write. Okay? But the second one, what else is going to happen? We just talked about it. What's going to happen to the number that it equals? The number that your second equation is going to equal, what's going to happen to it? Remember? You're going to make it the opposite. If it's positive, make it negative. If it's negative, make it positive. All right? Like Mr. Hager just said, put the sign. All right? The two answers that you get, I don't think this is on there. Yeah, you already have written on anything anyways. So the two answers you get are connected with the word and. So y or x equals 5 and 2. Negative 1 and 7. Whatever. Just going to make sure you put the word and. I think it might make a little bit more sense to you guys if we do an actual example. Alright, so first thing we're going to ask ourselves, is this absolute value equation ready to be broken? Can it break out of jail? Can we break it out? Look at it.
Yeah,
Joe, you say yeah, how come?
because there's nothing next to it.
There's nothing else around, right? There's no number here. There's no plus or minus a number here. We're ready to break it out. All right, we're ready to split it up. We're ready to split it up. So this is example 1A. You have a little box on the back of your notes, right, to write it in. All right, so we have to solve it and graph it. All right. So based on the notes that we just wrote, we're writing our first absolute value. Now we're splitting it. We're breaking out of jail because there's nothing else around, so we're good. No one's around watching. We can break up. Okay. Someone tell me, what's our first equation? What's it going to be written as?
X plus 1.
Right, Joe just said it. X plus plus 1 equals 3. Mackenzie, how is this different from that? What's the one thing that's different here than here? No bars, right? Because nothing else around, so we can split up. Okay? Now, this is where it gets a little bit tricky. What's one thing that's going to be similar to the one I write here and the one I already wrote? How are they going to be similar? They're both going to have what? Or no what? What aren't they going to have? Both of them. No, they're both going to have an X. Nothing inside the absolute value changes. No bars, right? When we're at this point, we can break out of jail. Get rid of the bars. We don't need them anymore. We're gone. We got out of jail. So I'm going to write X plus 1 equals 3. What's one more thing for the second equation that I write? What's one other thing that I have to make sure I do? What's one other thing I have to make sure I do? Xander?
You have to make the 3 negative.
Make the 3 negative. Because the 3 was positive, I do the opposite. I make it negative. There's my two equations. So that process right there is the only new thing. Splitting it up. One, exactly the same with no bars. The other one, no bars, but also making the number it equals opposite. So it's only that this process right here of splitting it up and breaking it out is the only thing that's new. Because now we're just getting into a situation where we just have to solve an equation. And that's why in the warm-up we did a couple where we had to solve equations. Right, this basic equation. This kind of goes back to what we did last week. Alright? So, Ginny, to solve this one, what do I have to do? Subtract 1 on both sides. Very good. I'm going to get X equals what, Jenny? 2. That's done. Now the good thing about these guys is it makes them a little bit easier. Whatever your first step is for this one is going to be your first step for this one. So if you identified your first step correctly in this one, you're going to do it correctly in the second one. So, Connor, my step is going to be the same exact thing I did here, I'm going to do over here. So what am I going to do?
-1.
-1, right? So I'm going to -1 from what?
1.
Yeah?
And 3.
Good. Make sure -3, right? Do you feel like you can do that math or no?
X equals 2.
Careful. I like X equals. They're both negative, right? We're not multiplying, right? Someone tell me the rule again when they're both negative and we're combining? Huh? It stays negative. I know my answer is going to be negative. And Joe, what do you do to those numbers?
You add them.
Add them, right? So that's perfect. -4, right? Keep the sign, add the numbers, right? One more thing I have to do. I'm missing something. I'm missing a word. What word should I write right here? What word should Mr. Hager type right in the middle? Nope. And. Perfect. Good, Madison. Right? We got to separate it with the word and. Why does that? Why? Here's the reason why. If I plug in this number for X, I'll get the correct answer. If I plug in this number for X, I'll also get the correct answer. Both of these are solutions for that absolute value equation. Because whatever's in that absolute value can't be negative. It has to be positive. All right? So I'm going to show you setting up a number line. All we're doing on the number line is you guys have to write it in yourself, write in the numbers. All right?
We can't fit that.
I mean, I don't even care if you write this note. Make sure you put a 0. Just know that don't put -4 over here on the right. The negative number should be on the left. The positive number should be on the right. Okay? All I'm going to do is to graph it. I'm going to put a point at 2. And I'm going to put a point at -4. All I'm doing is graphing those two numbers on the number line. That's all I have to do. No more. We're not to the point now where we have to draw lines to connect the dots. None of that stuff. All we're doing is putting those two things. Now, if I wanted to check this, right, all I'm going to do is let's check for 2 first. All right, I'm going to plug in 2 for X. So 2 plus 1 equals 3. 2 plus 1 is 3. The absolute value of 3 is 3. The absolute value of positive 3 is 3. Because the absolute value always has to be positive. So we know that's why it works. And we got negative 4 plus 1 equals 3. I'm going to take the sign of the bigger number, which is 4. That means it's going to be negative. 4 minus 1, 3. Remember, absolute value can't be negative. It has to be positive. Negative 3, like I showed you guys at the beginning, negative 3 on the number line is still 3 spots from 0. That's why it works. So the absolute value of negative 3 is 3. The only time the absolute value doesn't work, guys, is when the number that the absolute value equals is negative. Right? It's okay if the number inside the absolute value is negative, as long as it doesn't equal a negative number. So that's how we do it. That was a simpler one, guys, because there was nothing outside of the absolute value. Nothing outside. All right? Let's go down to this one. All I want you to do right now, listen to me. All I want you to do right now is break it out. Set up your 2 equations. You do not have to solve. Do me a favor.
Yeah.
Tell me my first equation.
2x plus 4 equals 8.
Right? Exact same thing, no absolute value bars. That's the only change. Exact same thing, no absolute value bars. Now here's the mistake I see people making. People want to go and just solve this. It's not wrong, but I would rather split them first and make sure they're all set, because then I know all my steps here are going to be exact. All the steps I do for this one will be exactly the same for this one. So I like to split them first, write both equations first, then solve the one on the left. If you go ahead and solve that right away, it's not wrong. I think it'll be a little bit better process for you guys if you split them first, set them both up, then solve this one. Because the steps you have for this one will be exactly the same for this one. Now, my second equation. Gemini?
So there's still no bars.
Yeah.
And there's 2x plus 4 equals negative 8.
Perfect. That's the only catch on the second one. That's why I saw some people having a little bit of difficulty. You've got to make sure, split it, make it opposite. Split it, make the number it equals opposite. Like I said, if you break it out, if you're gonna stay around town, if you're gonna go somewhere far, far away, people don't know who you are. You can stay as yourself, right? If you're gonna stay local, you might have to put a costume on or something, so you can kind of hide your identity. That's why we give this a negative sign. All right. Now we're at the point where we've done this before. We've solved equations. Remember, the only thing that's new is splitting, getting it set to break out, to split, to solve. This is all stuff we've done. We did this last week. You've done this in middle school, right? Z, what's my first step going to be in this one?
You need a -4.
-4? Where else am I going to -4 from itself, and where else?
Underneath the 8.
Underneath the 8. What do I get?
You get 2x equals
4, last step.
you need to
Divide by 2. X equals 2, right? Excellent. Now the steps I followed here are exactly the same here. Mackenzie, the steps I followed here are exactly the same here. So what I did here first is what I'm going to do there first. So what do I do first in this equation? What did I do over here? Not sure? Okay. Noah, what did I do first over here? Okay, I brought down the 2x, but before I did bring that 2x down, what did I do? What did I do here?
You -4.
-4, right? I'm going to do the exact same thing over here. -4, -4. Just obviously the number's going to be different because it equals a negative, but the step is exactly the same. Now somebody tell me, my answer here for this, -8 -4. Positive or negative? How many people say positive? How many people say negative? How many people aren't sure?
Oh, I know.
That's okay.
I know what you're saying.
X?
I think keep my head.
Huh? -12, right? Xander, do you remember, what's the rule again if they're both negative and I'm combining? Right, keep, again, we're not multiplying here. Keep the sign negative, add the numbers. Just like if it was 8, positive 8, and positive 4. They're both positive, doesn't become negative, they stay as 12. All right, so this cancels out. I did that work. On my left-hand side, over here, what do I put there? 2x. My last step in this equation is still my last step in this equation.
Divide 2 by both sides.
Say it, Joe.
Divide 2 by both sides.
Divide 2 by both sides. Divide by 2, divide by 2. X equals now negative divided by positive?
Negative.
Negative. All right?
Negative 6.
-6. Good job. X. There they are. All right? Now, I got to graph them, right?
Oh, I did.
Fred, what about 2? How do I graph 2?
We need to put it on positive.
Yeah, put a dot, put it, say who's gonna do it. Put a dot on positive 2. All right? Nathan, how about -6? How do I graph? Yeah, put a dot on -6. It's that easy. It's kind of like Mr. Roy. Why are you asking me this question? Put a dot on -6. You're done. What? Oh, ooh, whoa, I forgot something. Anybody know what I forgot?
To check.
I forgot a word.
Check.
Good job, guys. And Mr. Dave's gonna put it in. Beautiful. Perfect. Now, what does this mean?
That's.
X equals 2 and X equals -6. What does that mean?
Because it can be either one.
Exactly. Either of these will work as a solution. Because one of them will end up making this negative in here, which is okay. If it's negative on the inside of the absolute value, it's still going to come out as positive. We're measuring distance. All right. 1C, we're going to skip.
Thank the Lord.
All right.
Yay.
Again, just real quick, guys. Don't write this on your sheet. You don't have to. Do not write it. Someone tell me, is this raising? If you think this is ready to be split, if we can break this out of jail, raise your hand. If I can break that out of jail, raise your hand. All right. Connor, you're kind of like, ew. Why? How do we know we can? I agree you can break it out of jail. Why? Sophia.
Because there's nothing outside.
Yeah, there's nothing else outside of it. There's nothing to the left of it, nothing to the right of it. It's ready. All right. My first equation would be Connor. What would my first equation be? You don't have to write this down. What would my first equation be?
X,
Don't forget the 3.
3x plus.
No, don't add anything that needs to be there. It's the exact same equation. So what's the equation going to be? Tell me. You can do it. Yeah, 3x.
Equals 21.
Yeah, that's it. The first one is exactly the same.
7.
No, can you tell me the second one? The second equation? So the first one was 3x equals 20. That's the easy one, right? All you gotta do for that one is write it with no bars. The second one's a little bit more tricky.
3x equals -21.
3x equals what?
-21.
Yeah, just make it opposite, right? Again, we don't have to solve. That's all I want to do, make sure we can set it up. The rest, that's easy math. All right? Now, how is this one? Look at example 2a. How is this different from what we've done so far? Mallory?
But there's a number attached to the absolute.
There's a number attached to the absolute value. Now, Mallory, did we talk about that when we went through our notes?
Yes.
Okay, cool. So I can't break this out because someone's watching. I gotta get rid of that first before I can break out. I don't want anybody around when I'm getting ready to break out of jail. I don't want to get caught. Okay? So remember, we talked about this in the beginning, right? We did those couple situations where it's not ready to be, we can't break it out yet because we gotta get the stuff away. For this one, let's say you put a little sad face. What do we have to do? Anybody remember? To get absolute value by itself, what do we have to do? Mallory?
We're going to divide 2 on both sides.
Divide by 2 on both sides. Very good. So on this, here's my equal sign. Fred, on this side, I got 4 divided by 2. What would I get? 2. Perfect. On the other side, sometime by raising their hand, Sophia, what do you get?
Just
3y plus 5.
Just 3y plus
You don't
5.
need the plus.
Yeah. We didn't break out yet. We had to get that other person out of there. We had to go tell them to go do something else. I'm still in jail. Right, I got that person out of there, but I'm still behind bars. Right, I had to get the other thing out of there first. I still have the absolute value bars. I haven't broken it out yet. All right, listen to me. Take 45 seconds. Split it. Don't solve. Just split them. Let's come back together. We still got a couple more we gotta do. How many more we got left? We got one after this. So we may have a little bit of time. You guys expect, actually, we got a couple practice ones you guys to do. All right, so,
Oh, wait, are we supposed to graph this?
yes.
Oh, we don't have a graph.
I got the graph, right? Mr. Hager, delete the graph, get rid of that. The ones we do like this on the test, guys, when there's stuff on the outside and things like that, we're not gonna make you graph them. We're gonna make you graph the basic ones that are already set up to break out of jail. So this one, Mr. Fairbanks, tell me my first equation, please, sir.
3y plus 5 equals 2.
Excellent. 3y plus 5 equals 2. Mr. Kingsley, because I know you got it correct, as you and I talked about this. Will you just tell me my second equation, please?
3x plus 5.
Whoa, what's the variable again?
Y
Thank you very much. Yeah?
plus 5 equals negative 2.
Very nice stuff. Very nice stuff. Now, Miss Goodrich, can you tell me, that's Ginny's last name, Goodrich.
Oh, it is?
Yeah. She's named after the Goodrich Street School in Fitchburg.
Oh.
No, she's not. Miss
We're
Kennedy.
just used to her name being Genie in a bottle.
All right. What do you call it? Genie in a bottle?
Yeah.
All right, Genie. All right, Genie in a bottle. Can you tell me what the first step is for this one? Subtract 5. What else from what? Very nice. Can you tell me what you got when you did 2 minus 5? Beautiful. I did negative 3. Much better. Hey, Connor. I didn't do anything with that 3y, so what should I do? I'll cross this out. I agree with that. If I didn't do anything with it, does this disappear? Are you a magician?
Bring it down.
That's what I'm talking about, my man. I'm going to bring it down. Right? Do you think you know what to do here?
Put 3y on both sides.
3y.
Negative 3.
Negative 3. Sophia, help him out.
You divide 3 by 3y.
Divide by 3 on both sides, right? Remember, when we get to that last step, whatever number's with the variable, divide by it on both sides. Sophia, when you do that, what do you get? Negative 3 divided by 3.
Negative 9?
Yeah, not negative 9. We're not multiplying. We're dividing.
Negative 1.
There you go, better. Right, so y equals negative 1. Negative, I'm going to keep, guys, stay with me, we're almost done. I'm going to keep reiterating the rules, right? Negative divided by positive, negative. Negative divided by negative, positive. All right? Negative, positive divided by positive, positive. Don't change it. Don't make it harder than it needs to be. All right, over here. Remember we talked about this earlier. Exact same steps we follow here, the steps we follow here. Gemini, go ahead.
So you're going to subtract 5.
Subtract 5. Where else?
Negative 2.
Negative 2, very good. When I do that, what do I get?
You're going to cross the positive by the negative out, and then you're going to get negative 7.
Awesome. Remember, we're not multiplying, all right? We're subtracting. Same sign, keep the sign, add the number. I didn't do anything with the 3y, so Magician Kingsley. What do I do with that 3y? Do I wave my magic wand and disappear?
No, bring it down.
Bring it down, right?
Always make me smile more too.
Now, last step. Page.
Divide by 3.
Divide by 3. Oh my God, we're gonna get a fraction.
I got a decimal.
Why? If you did negative 7 divided by 3, you got a decimal. That's okay. That's not wrong. Again, on the test, guys, we're probably not gonna give you any that come out as a fraction. Right? The probably come out as a whole number, but for the case of this, it did. -7. And guys, if we get one, if we have one in the test that comes out as a fraction, we try to let you guys know in advance. We know if we get a fraction as an answer, you panic. But fractions do exist, right? They don't just disappear in math. We still have to deal with them, even though we hate them a lot. Right, good. Oh, I forgot something.
And.
Oh,
come on!
Estás haciendo rosa bien, right?
And, all right, cool. So now, think what we've done so far, guys. We did absolute value equations with nothing on the outside. How about this one?
Oh, this is,
There was one thing on the outside, right? How about the last one we do? What do you think it's gonna be set up like?
2 things on the outside.
Huh? What happened, Steve? There's only one thing on that one? Really?
Oh, snap.
Oh, okay.
X minus.
Now, hey, wait a minute. What if there was something else out here too, like a 2?
Then you have to, never mind.
If we had something like a 2 out here, all right, we'd have to again, just like there was a variable here, right? We would we would minus 5 on both sides first, then we divide. All right, but for this one, we don't have that. We don't got that. All right, so Nathan, what's the first thing am I ready to break out of jail?
No.
I can't. How come? What guy? What guy can't be there? Who's around that can't let me break out? Joe?
The positive
The
5.
+5. How do I
Subtract 5.
kick him out of there? Yeah, go bother someone else,
Go
right?
bother Malaria.
Go bother the 2, right?
Go bother.
Go bother that +2. All right. So on this side, on the left-hand side, what's left? On the left-hand side over here.
X minus 1 in the box.
X minus 1, the absolute value. Very good. On the other side, what do I have? 2 minus 5? Don't say +3, you better say negative.
-3.
Don't say 7, it ain't 7.
It's positive.
It's 1.
So we're going to get -3. That's a little bit different. All right? Because the ones we've had before, we had a positive the first time. Now we have a negative. All right? So what's my first equation going to be, Gemini?
If you're not gonna have any bars,
Yeah?
so it's gonna be x minus 1 equals -3 because it stays the same.
Exactly. The ones we've done, but most of them. Mr. Hager's saying no.
Yeah.
You can set up those equations, but what did we say about that kind of
We have
problem?
to switch it.
No, you can't switch it.
Sander. You have to change it.
You can set up your equations
There's
and
no
do all the work.
solution.
You can set up your equations and do all the work, but it won't mean anything.
There's no solution.
What?
That's why we gave it to you guys. No
No bueno.
solution.
No bueno.
But some guys, again, understand that if you have stuff outside the absolute value and it equals a negative, move the stuff around first, because it may make the number on the other side positive. All right? So in this case, we had a positive number. If you had something where off the bat, maybe it was like 2x minus 1 plus 3 equals 8. I don't know. All right? If we had something like that, or -8, right? Do all the work first to see if it makes it positive. If it doesn't make it positive, if it stays negative, right, then it's going to be no solution. Okay?
No.
So tonight, homework is 1.4. I think there's 6 problems
8.
on the homework tonight. No, there's 6.
Wait, how many did you?
I made it, I know.
I did.
Remember, review day, guys, tomorrow, very important you guys listen. Leave your notes, we might need them. All right, tomorrow is the last day of new stuff for this week. So we did equations with distributed property yesterday. We did absolute value today. Tomorrow we'll do one more thing. Those 3 concepts we'll be able to test on Friday. Nothing new Thursday. We're taking the whole period to review. Test on Friday. On Thursday at the end of class, we'll give you guys time to go out in Google Classroom, get the reference sheet. If you guys didn't do well last week on your test, I suggest, and Mr. Hager will too, do the reference sheet. Take the time to do it. We're making the reference sheet on the exact same program we make the test on. We're just changing the numbers. That's all we're doing. All right? So it'll be a good resource to have. Last academic week, this week before progress reports.